Hi, this is Lori and welcome to my series on the Pico W. This is part 6 in the Exploring LED Displays series. In this episode, we're going to start working with the 4-digit 7-segment display. So a 4-digit 7-segment display is just 4 of the 7 segments put together. I have a couple of them down here. The ones I got in my kits were these kind of smaller ones, and you can see there's all the pins. There's actually 12 pins on the ones that I'm going to be using in this episode. This one doesn't have the little colon here that you could use like for a clock, so it just has the digits with 4 of the decimal points. I have a larger version too that I've purchased over the years here. I'll work with these smaller ones. They're easy to fit on a breadboard for a breadboard project. All right, so well, everything we learned about the 7-segment display will apply here. The labeling of the segments is the same, A, B, C, D, E, F, and G, and the decimal point. And then we're just going to combine them and have 4 of them on one display. So to do that, how it gets wired up is there's now 4 more pins that tell us that connect to each of the digits and sort of activates that particular digit. So there's a D1 here, you can see at the pin 12. There's a D2, a D3, and a D4. And I kind of have them labeled down here just to say, you think of the D4 as perhaps being the ones place, the D3 would represent the tens place, the D2 the hundreds place, and the D1 the thousands place if we were putting those kinds of decimal numbers onto this display, which I think is typically the purpose. We want to read out some data from something we're doing perhaps. So that's how this display is, and you can see the other pins are the segments for A, B, C, D, E, F, and G, and then the decimal point. So they're kind of a little bit jumbled around, and I think it's just laid out for convenience of the wiring. These are just like the single digit 7-segment display. We can have a common cathode or a common anode, and in this case with the common cathode we'd connect the control pins into power, and that would mean that they're off, and if we have it grounded or a low signal, then that would turn on those segments in that digit, and the common anode would be the opposite of that. All right, so our first question is whether we have a common cathode or a common anode, and so I set up another one of those kind of testing breadboards here with the 2 different kinds. I happen to have both in the kits that I purchased over the last couple years. So I have an anode one here and a cathode, and so this is how I just sort of puzzled out which was which. I put some current limiting resistors on each of the digit control pins here. So you can see there's 4 of them for each, and they're connected into the appropriate place. So for the anode, I would connect it through to power. So the other side of this resistor connects into the power rail. And for the cathode, then I connect the end part of the resistor to ground. And now then to light the segments and just make sure they're working and everything, you can just go along and find the pins here and connect it in. For the common anode, I'd connect it into ground, and I would light up all the segments there that are associated with that pin. And you can move around, and you can see that. And there's the decimal point, and so forth. So that is a common anode. And that's how I would check for that. And then the common cathode here, we'd have the opposite sort of connections. So let's light up here. The A segment here at the top, and I think B is the one here on the end. Gotta get the right one. There we go. So that's a common cathode. Now for the rest of the series, I'm going to use the common cathode. It seems like that's more common, But all you have to do is just kind of flip around the logic of any of my programs. If you happen to have common anodes, you just flip it around and connect it appropriately. All right, here's our circuit for this episode. We'll have our Pico, we'll have our 4-digit display, and we'll have 8 current limiting resistors on here. So the idea will be that we will use persistence of vision. If we need to have more than one of these digits illuminated at the same time to display a number, then we're going to loop through them very quickly using persistence of vision so that it looks like the number is always on. And we'll simultaneously, for the digit that's currently being shown, we'll be able to simultaneously turn all that on because we have current limiting resistors for each of the 8 segments within a digit. So that should work pretty well, and that's how I decided to put it on. Again, just with as we had with the original single 7-segment display, you will see some people just put resistors on the digit control pins, and again, I think that's okay, but you do run into the issue that you're turning on multiple LEDs within a digit, and this one resistor is providing all the current limiting resistance for whatever ones you have on, and so a 1 versus an 8 will have a slightly different brightness that way. It may not protect the LEDs sufficiently enough when you have lots of them on. So I do think it's a good idea to go ahead and use the resistors and protect the LEDs that way. All right, before we start doing some programming, we'll go through quite a few programs, maybe more than's necessary, but I really played around with this a while. Just enjoyed seeing how it worked and trying different ideas of how to display numbers and information and access all the different parts of the display. So just first, I thought it's always good to see something in real life versus something on a fritzing diagram. These are as we said before with the 7-segment display, these are hard to wire up and keep it all together. I again made my own jumpers and to connect everything up, and I can tell you I wired and rewired this several times to make sure I had everything connected into the Pico, through these resistors back to the display, and you can see these long ones jumping for the digits here in yellow. So it can be a little frustrating, and if you jiggle this a little bit, even if you're using nice wires that you've set up yourself, they can come loose pretty easily. So if you're trying to do this, don't give up. You will eventually get it all connected and get it working, and then they're a lot of fun to play with. All right, well, let's start with our first program. The first program I put together was pretty similar to the first one I ran for the 7-segment, a single 7-segment. And that was just kind of lighting all the segments, kind of top to bottom, and then turning them back off, going bottom to top. So that's what we did the first time with the single. So let's try this with the 4-digit. And then we'll now have to loop through the 4 digits as well as all the segments within a digit. We'll need all the same libraries, machine and time, and we'll set up our segments. So we'll take the pins for the segments A through G and the decimal point and connect them up to pins on our Pico as outputs. And then we need to set up the control pins for the digits, so D1, D2, D3, D4 on pins on our Pico as well. And then I created a couple of lists, very similar to that previous program, where I put the segments within the digit in the order to light them top to bottom this way. And then I put the digits in order. So this just goes through and makes sure all the digits are turned off in case we abandoned a program and left some segments and digits activated. And then I made sure all the segments are off as well, just to avoid any carryover. We'll set up a couple delay times to control the going up and down through each digit. So we'll loop through the digits, and we'll turn on the first digit, and then we'll turn on the segments top to bottom, and we'll sleep a little bit, and then we'll turn off the digits bottom to top. So we'll just reverse the order of the segments. So that's another way you can reverse a list, using reversed. And then we'll turn that digit off and come around and get the next digit and do the same thing there. So we're only going to have one digit lit at a time going up and down. And then we'll use the try and accept. I haven't been talking as much about this in the last couple of episodes because I think people are starting to get the idea. I tend to use try and accept and keyboard interrupts to close off programs so that all the all the LEDs get turned off. So that's what we're doing with the keyboard interrupt. All right, so let's run this first one here. And check the monitor, see if it's filming okay. Looks like it is. Yeah, so you can see it moving. And we're able to light all the segments. They're all working. So it's also a nice little test program. Make sure every segment is working and nothing's burned out, for example. Yeah, okay, so we got the basics of how to light every one of the segments in all 4 digits. Well, next program, we'll go ahead and put some numbers on our display. So we'll go through 0 to 9 and then move to the next digit and the next digit and the next digit. So the same setup. There are certainly more efficient ways of setting up all these control pins, but I just wanted to be pretty explicit so people knew where I connected everything in. So that's the reason why I left it maybe a little more verbose than it needed to be. Set up all our lists that we had from the previous program, and then we brought in our list of lists for how to make the digits on a 7-segment display, and our function for displaying a digit on a particular digit on one of our digits in our display. So this little function will manage that and grab the correct. So you give it the digit you want to display, and you grab the correct digit out of the list of lists and light up the appropriate segments. We'll have a little delay in here. We'll have some code to make sure everything's turned off. And then we'll get to our pretty simple try and accept. So we're going to move through the digits, and then we'll count from 0 to 9 and get that done, and then move to the next digit and the next and the next. And when we get a keyboard interrupt, we'll stop looping through the digits and doing that. All right, so it should be pretty straightforward. And you can see it counting up all the way. It moves over to the next digit. And you notice I went through the digits in a kind of reversed order this time. I actually put D4 first, D3, D2, and D1. And you'll see that becomes more important in how I decided to handle putting numbers, bigger numbers, onto the display. So I wanted to get the ones place dealt with first, and the tens place, the hundreds place, and thousands place. So I put the digits in this order for that reason. All right, so that works. We know how to put digits on a particular one of our digits, numbers on one of our particular digits. So let's move on to the next program. All right, so for our next program, we want to be able to display data in all 4 of the digits simultaneously. And in that, we're going to use persistence division. So I'm going to kick off this program just so you can see what it does. So you can see we're going to count up for all 4 digits from 0 to 9, and they look like they're all on at the same time. All right, let's look at the code. I'll turn that off, and then now let's look at the code that we would need to make that happen. We have the same setup of pins, our lists, our list of lists for our digits, our functions for that. And the new thing we have to have is we have to have two different kinds of timing. We need a timing for the persistence division. How quickly are we going to move through the 4 digits in the display? And that will measure in microseconds, and I have it set to 2,000 microseconds. That seems to work pretty well with the display I have. And then how long do we want each of those digits as we count from 0, 1, 2? How long do we want that to last? So I want it to be a second, but I have a display time. I have that in milliseconds. Well, I have some code here, just like before, to make sure everything's turned off before we start. And then we're going to start looping through the numbers 0 through 9. And we'll start a clock so that we can make sure we showed that digit for as long as we wanted. And so that's what this while loop will do. It'll keep going around until we exceed the display time we asked for. And it'll loop through the 4 digits very quickly using our microsecond delay. So this is where the persistence of vision part is coming into the code. So we turn on the digit, we show the digit we wanted, we wait the delay time, and then we turn that digit off and we go to the next one. So that's how we loop very quickly through those digits. So again, let's run one more time. And so yeah, it looks to us as though all of them are on the same time, but they're actually not all on exactly at the same time. But we're moving so fast that it looks like it is. And that's going to be really important to using the display as we go forward. The next 4 programs are going to kind of build to creating a counter for our 4-digit display. So we're going to count from 0 to 9,999. And now we need to be able to direct each of the digits here to the correct one on our display. And so we'll need to pull off what's in the ones place, the tens place, the hundreds place, and the thousands place. And so this is just sort of a little math trick for grabbing each of these digits here and then being able to then assign them to the digit for the display. So you do a modulo in increasing powers of 10, and you do integer divides to get those digits. And so I'll leave that to you to play around with and prove to yourself it works. And then what I'm doing here is I'm just doing it to the shell at this point. We're just going to make sure this works, and so we'll use an F string to print out the thousands, hundreds, tens, and ones, and we'll use the end equals /r to just keep replacing. And so we'll just count, have a little delay in here so we can watch the counting. All right, so let's run this and see how it looks. So there we go. Yeah, okay, so we got our 4 digits. It seems to be working correctly. We're working with each of the digits individually. We're not printing I to the screen. We're printing our calculated values for each of the places. So that seems to be working pretty well. So we've got that figured out. On the second program, we're going to go ahead and do the counting from 0 to 9,999. So we'll set up the display as we have been. We'll also make our list of lists for the segments that we need to turn on to form each of the digits. You'll notice that I have an additional one in here, which is a blank line with all the digits, all the segments turned off. And I found that if I didn't include this as I'm looping through, I would get some carryover between the digits when I'm looping for the persistence of vision through the 4 places. So I put in this list that I'm calling blank, and it's at the 10th place, right? Yeah, the 10th place, or the 11th list in the list of lists, since this one's 0. So this is the 10 position, index 10. I guess that's the word I'm looking for. Okay. And all the same kind of setup we've had before. But now as we go through our numbers 0, 9,999, we're going to break off the digits that we need in each of the 4 places. And we'll put that together in a list. and I'll print that to the screen just like we were doing in the previous program, just so we can keep track. Then we'll start our clock ticking so that we can display the count for a certain period of time. And you saw back here I had a display time of half a second, and then this is our persistence of vision timing, and I used 1,000 microseconds for that. And you can play around with that number. You can do different things with it. I've had it in different settings before, whatever works for you. And so yeah, now we're going to display that number. So we're going to loop through the 4 places, and we'll display the appropriate digit for each one. And then this is where we show that little blank. We blank everything out so that we don't get some carryover. And again, that's just something I observed, and as soon as I put that in there, I quit getting the carryover. So I'm not entirely sure why that happened, but this seemed to fix it for me the way I have it coded. There might be a better way to code it than what I did. All right, so yeah, it gets a little more complicated when we want to do this, but let's kick it off and see it go. There we go. Yeah, so we're counting just fine, getting the digits in the right place. So that's working pretty well. Now, what I don't like about this counter is I wouldn't want the zeros, the leading zeros here, to be on the counter, because it just makes it a little harder to see the count when it's in these smaller numbers. So I'd like those zeros not to appear unless, you know, that digit was actually needed to display a number. So I started thinking about that and thinking about how I would make that happen. And so that's what the next 2 programs are about. So to figure out how to eliminate those leading zeros, I first just tried to eliminate it from printing into the shell first. So we'll count again through our range of numbers, pick off the digits that we need for the ones, tens, hundreds, and thousands, and then we'll look at those digits, and we got to work our way backwards. So first we'll say, hey, is the digit for thousands equal to 0? If it is, don't show it. Make it a blank printing character. And if that's true, if the first ones might be 0, well, let's check and see if any of the others are also 0. So if that's a 0 and then the hundreds is also a 0, then we want to blank that one out. And if those 2 are 0, let's check the tens, see if it's 0, and blank it out if we need to. And then we'll print that out to the screen. So let's run that, and you'll see how that works. So now we don't see the leading zeros over here at all. And we'll wait till it kind of gets to 10 here, and so you can see it working appropriately. Not allowing those leading zeros. So that's the code that we're going to use to further refine our counter. Okay, finally to the last program for this episode. It's going to be a long one, I think. So we'll just add in that code to the code we had previously, and that should fix it so we don't show the digit there. So let's go down to where all that action happens. So here you can see that it's just a little bit different. So if the digit is a 0 for the thousands, we check that one first. If it is, use the blank line for that place, and then check the hundreds. If it's also 0, use the blank line, and let's check the tens as well. And if it's also 0, use the blank line. So that should take care of it, and our counter will be a little more sophisticated than the previous one. So let's kick it off and hope it works. Oh yeah, that looks great. I really like that, and I think that's a little more sophisticated and a little nicer looking counter. Well, that's plenty for this episode. Stay tuned for the next episode. We'll go a little bit further with these displays and include our shift register, and we'll also include another type of network resistor. As always, thank you for watching.